In this video, we're going to solve simultaneous equations by the method of elimination. Let's look at a typical equation that you might have seen in the past. We could have, for example, 2x minus 4 is equal to 6. To solve this equation, we would add 4 to both sides of the equation. So adding 4 to both sides, we'd have now 2x is equal to 10. We would divide both sides of the equation by 2, and we'd see that x was equal to 5. We have now one unknown to solve for, or if you like, one variable to solve for. We're trying to find x. If we've only got one unknown, we need one equation. What we're going to look at in this video is when we have simultaneous equations. An example might be 2x plus y is equal to 6, and 3x minus 4y is equal to 1. So this time we have two equations. We generally label them 1 and 2. We have two unknowns to solve for. I need to solve for x and I need to solve for y. So if I'm solving now for two different variables, I need at least two different equations. I can't do it with just one equation. These are examples of linear simultaneous equations. They're linear because the power on x and the power on y is just 1 instead of x squared and y squared, or y cubed and x cubed, and there's no multiples. So we don't have x, y, for example. So these are linear simultaneous equations, and what we're going to do is look at the method of elimination. This is just one of the ways in which you can solve simultaneous equations. Let's start off and have a bit of intuition of what's going on here. What I'm going to do is take x, and I'm going to let x be equal to 3, and I'm going to take y to be equal to 4. So what I've said is the solutions to the equation that I'm about to write are going to be x is equal to 3 and y is equal to 4. If we look at this, we could write now that 5 lots of x plus y is going to be equal to a certain value. So 5 times by 3 is 15, plus 4, that's going to give me 19. I could do another one. Let's do 2x plus y. So 2 lots of 3 is 6, plus now the 4, that's going to give me 10. So what I would do is have a simultaneous equation like this, and I'd want to solve for both x and y. What we first try and do is get now an equation involving 1 and 1 only. So we don't want x and y, we either want x or we want y. If we look at this now and we think to ourselves, well, this is equation 1 and this is equation 2, and I wanted to get rid of either the x's or the y's by eliminating them, what could I do? Well, I can see now that I've got this y added to both of these, and we've got a slightly different value here and here. We've got a slightly different value here and here. If I did equation 1 minus equation 2, I would have 5x minus 2x, and that would give me 3x. I would have now y minus y, which would give me 0. And then I'd have 19 minus 10, which gives me 9. So what I can do here is eliminate y by simply subtracting down. And the reason I can do that is that the value, the coefficient or the number in front of the y is the same, and that's just 1. So from here I can see now that I can solve for x. So 3x is 9, so x is going to be equal to 3. So from these simultaneous equations, I've managed to eliminate one of the unknowns, and it will allow me to solve for the other. At this stage, I can find the value of y by simply substituting it into either one of the equations. It will work for both. So what I'm going to have is the second equation. I've got 2x. Well, we know x is going to be equal to 3 plus y, and that's going to be equal to 10. So 6 plus y is going to be equal to 10, and we can see now subtracting 6 from both sides of the equation, y is going to be equal to 4. And we knew that. So with two unknowns, the unknowns being x and y, and two equations, we can go ahead and solve. What we saw here is that I subtracted the equations once the number in front of y was the same and the signs in front of that term were the same. So let's look at another one here. So if I had now 3x minus y. What's that going to give me? Well, 3 lots of 3 is 9 minus 4. That's going to give me 5. Let's do another one. Let's say I've got 4x plus y. So what's that going to give me? That's going to be a total of 16. Now this time I can again eliminate y from these equations and get an equation that just involves x. But if I subtract them, that's not going to happen. What we could do though is add them. If I add 1 and 2, so equation 1 and 2, I can eliminate one of the variables. If I add there, I'm going to get 7x. Adding minus y and plus y is going to give me 0. And adding 5 and 16 gives me 21. So 7x is 21. So x is going to be 21 divided by 7, which is 3, which we knew anyway. And we can simply substitute that back into either of these equations to see that it's going to work. So let's put it in the first one. 3 lots of x, when x is 3, minus y is equal to 5. Looking at it, the algebra is probably slightly easier on the second one, but it really doesn't matter. So 9 minus y is equal to 5. Subtracting 5 from both sides and adding y, we can see that y is going to be equal to 4. We need to check that that works for both equations. We could see this anyway. If we put it back into this one, 4 lots of 3 is going to give me 12. 16 minus 12, y is going to be equal to 4. So what we've seen from here is that once the value or the number or the coefficient in front of either of these terms is the same, we can eliminate them. If the signs are different, we're going to add. If they are the same, we're going to subtract. We solve for one and we plug it back in to solve for the other. So you're simply substituting in or plugging in to either equation and it will work for both. What we're going to do is work through a few different types of questions similar to these that take slight variations and will make them progressively harder. So let's start off. What we've got is the first one. 3x plus y is equal to 7 and 2x plus y is equal to 6. What I've done here is written now an algorithm, or if you like, a set of instructions to follow to carry out the elimination method of solving these equations. So we need to make x or y, either the x or the y, the same. Now we can see that the y's are the same, so I don't need to do anything here. In later examples, we'll look at changing these. What we now do in part 2 is subtract if the signs are the same, or we add if the signs are different. So we can see now that we've got one y and one y. The positive in front of these means that I'm going to subtract them. So what I can write is 3x plus y is equal to 7 is equation 1. Then I've got 2x plus y is equal to 6, and that is equation 2. So if I do equation 1 minus equation 2, we've got 3x minus 2x, that's going to give me x, plus 0, and that's going to give me 7 minus 6, which is going to give me 1. We can see x is going to be equal to 1. I've solved now the equation for one unknown. So that part is done. We've done this one, that was already done for us. I've subtracted, I've solved the equation for one unknown. I now need to substitute the answer back into any equation, and again we'll see why we say any later, as we might be changing some of these, and solve for the other unknown. So we need to solve for y. So if I put this back in, what we're going to have now is the following. It's either one. I'm going to take equation 2. We know that x is 1. 2 lots of 1 plus y is equal to 6. So from here now, all we need to do is subtract 2 from both sides, and we can see now that y is going to be equal to 4. So does that work for the first one? Well, 3 lots of 1 is 3, plus 4 is 7. So yes, these are the solutions to our simultaneous equations. With simultaneous equations, we can have more than 2. At this level, we will simply solve 2. We'll use this method of elimination, and it is fairly straightforward once you've done a few. Okay, let's look at question 2. So this time, instead of x and y, we've got g and h. It doesn't matter. These are just 2 unknowns or variables. If I look at the moment, I can see that the value of the coefficient or the number in front of g is the same. It's 1 and 1. I've got plus 1g minus 1g. So make x or y the same. Well, that's already done, so we can tick that off. We need to subtract if the signs are the same and add if the signs are different. When we're talking about the different signs, we're talking about those in front of the terms that are equal. So here now, if I just get rid of that, we can see I've got a positive and a negative. We can tell this is positive as we're not told otherwise. So what I'm going to do is simply add the equations. This will eliminate g from the equation, or both equations. It will give us one equation that has h and then numbers, and we can simply go ahead and solve. So what we're going to do is add them. So this time 1 plus 2 as the signs are different. That's going to give me 0 plus 4h is going to be equal to 10 plus 6, which is 16. Dividing both sides by 4, h is going to be equal to 4. I can now choose either of these equations. This is the easier one to choose, so substituting back in. So I've now done that part. I've solved for one unknown. I'm about to substitute back in. So into equation 1, g plus h, well h is 4, is equal to 6. So we can see that g is going to be equal to 2. So that gives me g. We sub back in to solve for the other. Now we need to check that it works. So for this one, we can see now that 4 plus 2 is 6. If I sub it back into this one, minus 2. Remember, g is 2, so minus 2 plus 3 lots of h, which is going to give us 4. Does that equal 10? Well, that's minus 2 plus 12, and that certainly does equal 10. So it satisfies both equations, therefore it's correct. It needs to be correct for both. Okay, let's look at the next one. We can see the value of x is the same. So all we're going to do now is simply subtract, as the value of x is the same and the signs are the same. So make x or y the same. That's already done for us. The x's are the same. We're going to subtract if the signs are the same. They're both positive. So we've got now x plus 9y is equal to 13, equation number 1. And then we're going to have now x plus 3y is going to be equal to 7, and that's equation 2. So I'm going to do 1 minus 2. That is going to give me 0 plus 6y is equal to 13 minus 7, which is 6. 6y is 6, so y is going to be 1. We sub that back into either equation. I'm going to put it back into the top one. Probably easier to put it in the second one. It really doesn't matter. X plus 9 lots of y, which is 1, is 13. So we can see now that x is going to be equal to 4. So that's all we've done. Let's have a look at this if it was the other way around. So all of these now, we can tick these off and you're just simply following them through. So checking it works for both, sub them in. We can see it works for this one. We can see it works for that one. Therefore, these are the correct solutions. Now, what happens if you had it the other way around? Let's say you had equation 1 was x plus 3y is equal to 7. And equation 2 is x plus 9y is equal to 13. So let's say you had this scenario. You can still do the same. You can subtract downwards. It gives you here minus, so 0 minus 6y will be equal to 7 minus 13, which is minus 6. If we do a minus divided by a minus, we're going to end up with a positive. Alternatively, if you're in this situation, you can simply swap them around and do what we've done before. Either way, it does not matter. It doesn't matter which is on the top. You decide, and you can make your life easier by avoiding negatives by changing them over. Okay, let's look at this one right here. We can see now that the y's are the same. We've got 1y. We've got a plus and a minus. Therefore, we're going to add these. So 3x plus y is equal to 25. We've got x minus y is going to be equal to 3. Equation 1 and equation 2. We've got the x's or the y's the same. Well, the y's are the same. We're going to add, as the signs are different, and solve for one unknown. So adding 4x plus 0 is equal to 28. Dividing both sides by 4, x is going to be equal to 7. We can substitute that back into any one of these. It really doesn't matter. I'm going to put it in the first one. So we'll have 3 lots of 7 plus y is equal to 25. That's equation 1. So 21 plus y is equal to 25. Subtracting 21 from both sides, y is equal to 4. So does that work for this one? Well, x is equal to 7. 7 minus 4 gives us 3, so these work. We substituted back in and we have solved. So there we go, nice and straightforward. These now are linear simultaneous equations and we're using the method of elimination. Okay, let's now look at these ones. This time we can see now that neither in the first case are the x's the same nor are the y's the same. What we need to do is make them the same. If I look at this second equation, if I multiply the whole equation by 4, I can have 4y. I do have the alternative of making this one 6x and this one 6x, which is the lowest common multiple of 2 and 3, but it's a lot easier to simply multiply equation 2 by 4. So all I'm going to do is that I'm going to write there that I'm going to multiply this by 4. So equation 1 remains the same. 3x plus 4y is going to be equal to 20. That's equation 1. I'm now going to have 8x plus 4y is equal to 40, and that is equation 2. What I've done here is multiplied each term, and you need to check that you're multiplying by each term to make the y's the same. What I'm going to do here now is subtract. The y's are the same, the signs are the same, so we've done the first part, and I'm going to subtract. This time I'm going to do 2 minus 1 to avoid the negatives, but you can do 1 minus 2. So 8x minus 3x is 5x. 4y minus 4y is going to give us 0. 40 minus 20 gives us 20. 5x is 20, so x is 20 divided by 5, which gives us 4. I can substitute this back into any equation that I like. To go ahead, I'm going to put it back into equation 1. So we solve for this one. We're now going to substitute back. So into equation 1, 3 lots of 4 plus 4y is equal to 20. That's going to give me 12 plus 4y. So 12 plus 4y is equal to 20. Subtracting 12 from both sides, 4y is equal to 8 and y is equal to 2. So we got x is 4, y is 2. Make sure you're solving for both. Many students just forget and leave them out. So they do one and don't do the other one. Does that work here? Well, 8 times by 4 is 32. 4 times by 2 is 8. Add them together and we get our value of 40. So yes, it holds true for both of these equations. Let's do question number 2. We've got 3x plus 4y is equal to 24 and x plus 5y is equal to 19. This time we can see that the x's aren't the same and the y's are not the same. The easiest thing for me to do is multiply equation number 2 by 3. That will give me 3x and then we can look to eliminate. So all I'm going to do is multiply the second equation by 3. I could have multiplied this equation by 5 and this one by 4 to get 20y. That's entirely up to me. At the moment I don't need to because I can make my life slightly easier by simply multiplying this equation by 3. So we have 3x plus 4y is equal to 24. And now we have 3x plus 15y is equal to 3 times by 19, which is 57. So this is equation 1, this is equation 2. If you like, you can rewrite equation number 1 underneath. If you think it looks nicer and makes things easier, you can go ahead and do this. So what we have now is equation 2 and equation 1. I'm going to do 2 minus 1. The reason I'm going to do that is we have a positive and a positive. The signs are the same, so we subtract. It's the sign in front of the value that is the same. So we've done this part. We're now going to subtract. So if I subtract downwards, we're going to get 0 plus 11y, and that's going to be equal to 33. 33 over 11 is going to give me y is equal to 3. I'm now going to substitute that back, and it's entirely up to me. I'm going to put it into equation 1. If I do that, I've got 3x plus 4 lots of y, which is going to be 4 lots of 3, and that's 24. So from here, I can see I've got 3x plus 12 is equal to 24. So 3x is going to be equal to 12, and x is going to be equal to 4. So does that work here? Well, 3 times by 4 is going to give me 12. We're going to have 15 times by 3, which is 45, and that does equal 57. So we solved one, we substituted back in, and we've checked. Don't be alarmed if sometimes your answer comes up to be now negative, or it comes up to be a non-integer, so a decimal or a fraction. Don't worry about it, it's perfectly fine, just check it works for both. So on this one, what I'm going to do now is multiply the second equation by 2. So I'm going to have now 2p plus 11q is equal to 34. That is equation 1. Multiplying equation 2 by 2, I get minus 2p plus 14q, and that's going to be equal to 16. Make sure you're multiplying each of these terms by 2. It's a common error. Students often just leave 8 at the end, or 7q. I can see now that the value in front of the p, the coefficient or the number, is the same. The signs are different, so I'm going to add them. I'm going to do 1 plus 2. That is going to eliminate now from the equations p. So I'm going to have now simply, and I'm not going to put 0 as I won't be doing from now on, we're going to have 25q is going to be equal to 50. Q is going to be equal to 2, and we can go ahead and solve from here. So if I put this in entirely up to us, I'm going to put it in the top one. It makes things slightly easier. 2p plus 11q, or q is going to be 2, is 34. So 2p plus 22 is equal to 34. That gives us that 2p is equal to 12 by subtracting 22 from both sides, and p is equal to 6. Let's just check that in here. Minus 2 lots of p is going to give me minus 12, plus 14 lots of 2 is going to give me 28. Does that equal 16? The answer is yes. So it works. Okay, this one here, let's just do this one quickly. This one, I would multiply the second equation by 3. That would now allow me to add the equations and eliminate y from them. So quickly looking at that, 4x plus 3y is equal to 17. That's equation 1. 9x minus 3y is equal to 9 becomes equation 2. The reason I've done that is so that we have now the value of y to be the same. So if I do 1 plus 2, that will now eliminate y as the signs are different. So that's going to give me 13x, and adding these together will give me 26. Dividing both sides by 13, x is 2. We can go ahead and sub in and solve for y. Make sure you're subbing in and solving. Don't just leave your answer like this. If I sub in now, I'm going to put it into equation number 1. It will hold for both equations. 4 times by 2 plus 3y is equal to 17. So we can see now that 3y will be 17 minus 8, which is going to give us 9, and y is equal to 3. Does that work for the second one? Well, 9 times by 2 is going to give me 18. 3 times by 3 is 9. 18 minus 9 is 9. So yes, they are correct. So in these particular cases, I've simply changed one of the equations to match the other. That certainly won't always be the case. So if we look now at some slightly different ones, this time we can see neither the x's nor the y's are the same. I've got 2 different approaches with this, and I'm going to show you both ways. We could now make these both 10x. That's the lowest common multiple of 2 and 5. It's first number 2 and 5 going to. With this one, we could make this 12y. That's the lowest common multiple of 3 and 4. My first method is going to make the x's the same. So all I'm going to do is multiply this equation by 5 and this equation by 2. If I do that, I'm going to have now equation 1 will be 10x plus 15y is equal to 45. That's equation 1. Multiplying equation 2 by 2, we're going to have 10x plus 8y is equal to 38. So we can see by multiplying now, it's essentially you multiplying that one by that one and that one by that one, 5 and 2, because it will give us the lowest common multiple. So what we're going to do then is now 1 minus 2. 10x minus 10x is going to give me 0. 15y minus 8y is 7y. 45 minus 38 is 7. So y is equal to 1. We can substitute that back in. Now, I can substitute this back into any one of these equations or any one of these equations. It does not matter. It's my choice. So if I put now back into this one here, y is 1, we've got 2x plus 3 lots of 1 is equal to 9. So we can see subtracting 3 from both sides, 2x is equal to 6 and x is equal to 3. If I substitute it into this one, we'll see it works. 10 times 3 is 30. 8 times 1 is 8. It's 38. It's just easier to solve here. Okay, let's say I didn't take that approach and instead I said to myself, well, I'm going to make the y's the same. If I make the y's the same, I'm going to turn these into 12y. So I need to multiply the top equation by 4 and the bottom equation by 3. So let's go ahead and do that. That's going to give me 8x plus 12y is equal to 36. The bottom equation multiplied by 3, 15x plus 12y is going to be equal to 57. We will call this one equation 1 and equation 2. Here, let's just put a y here. Here, we want to now eliminate the y's. If I do 2 minus 1, and just rewriting now 1 here, if you like, you don't have to. It might make your life significantly slightly easier. What we're going to do is do 2 minus 1. So if I do that, I'm going to end up now with 15x minus 8x, that's 7x. The y's are going to cancel, 57 minus 36 is 21. We can see that x is equal to 3. So this time I've solved for x first. Now I'm going to solve for y. We can plug it back into either. I can put it in this one, or if I want, I can stick it into any of those two. I'm going to put it in this one right here. We're going to have 8 lots of 3 plus 12y is equal to 36. So 12y is going to be 36 minus 24, which is 12. And we can see that y is equal to 1, and we already knew that. So this now is when we've got two that are going to be different. All we're doing is simply making them the same. I generally prefer to make the middle ones the same. You certainly don't have to, I just prefer. It's just a personal preference. Really not fussed, you decide. So with this one, I could alter these now into 39s, or I could alter these ones into 10s. That's going to be easier for me. So multiplying this one by 5 and this one by 2, that's going to give me plus 10y and minus 10y, and I can go ahead and eliminate. So we're going to get 15x plus 10y is equal to 70. We're going to get now 26x, so let's write this in, 26x minus 10y is equal to 12. Equation 1, and then we're going to have now equation number 2. So I can see that the y terms are the same, the signs are different, so we're going to now add them. So we've done this part, we made the x's the same, or made the y's the same, so I'm just going to add them. So 1 plus 2, 41x plus 0 is going to be equal to 82. So x is going to be 82 over 41, which is 2. And I can substitute this back into any one of these. I'm going to put it back into this one as it's so much easier. So 3 lots of 2 plus 2y is equal to 14. 6 plus 2y is equal to 14. And we can see from here that 2y is equal to 8 and y is equal to 4. We need to check that in the other equation. So if I put it in here, 13 times by 2 is 26, 5 times by 4 is 20, 26 minus 20 is 6. Let's have a look at the next one. The next one we have here is going to be a choice for us. The lowest common multiple of 16 and 5 is 80. Therefore, I would change this one now to 6's. I've multiplied this equation by 3 and this equation by 2. So quickly doing that, multiplying the top equation by 3, 6x plus 15y is going to be equal to 39. So I've multiplied each of these terms by 3. Multiplying each of these terms by 2, that will give me minus 6x plus 32y is equal to 8. We can see I've got plus 6x minus 6x, so these are the same 6's. We're going to add. Adding will eliminate those, so that gives me 47y is equal to 47 and y is equal to 1. Substituting that back in, it's entirely up to us from here. I'm going to put it back into this one. 6x plus 15 lots of y is equal to 39. So we can see that 6x is 39 minus 15, which is 24, and x is going to be equal to 4. Does that work for this one? 13 times 4 is 42, minus now the value of y on here. So if we just check that, does that give us 6? So is this correct? Okay, let's just check which one. We're actually on this one, aren't we? That's why it's not going to work. So let's try it on this one. Let's put it in here and go ahead and solve. If we do that, let's just check I've got the right one. Subbing it back into any one of these, we should see that it's going to work. So x is going to be equal to 4. I'll assume that's going to be correct rather than me putting it back into one of the wrong ones. I've put it back into this one right here and it does solve. So do check that you're not losing your mind and doing the wrong one. Okay, this one right here, I've got the choice. I can turn these into 20s or these into 30s. It's entirely up to you. If the signs are different, I generally prefer to change that one. I said the middle one, but it really is entirely up to you. Okay, so there we go. There's some examples. Okay, let's look at this one right here. We've got these two minuses. Now, often this causes a little hassle. What I'm going to do is deal with this one here, and I'm going to make now the p's the same. So what I'm going to do is multiply this one. So with this one, what we're going to have is multiplying this one by 5 and this one by 2. Let's make sure I get the right one this time. We're going to have 10p minus 40 lots of q is equal to minus 10. That's equation 1. That's done. Let's now multiply this one up. We're going to multiply this one by 2. That gives me 10p. Then we're going to have now minus 12q. And that is going to be equal now to minus 10. Okay, so what we've got here is a slightly different scenario. So let's call this equation 2. We're going to subtract downwards. This is where we need to be careful. What we're going to have here now is the following. These are going to give us 0. Minus 40q minus minus 12q is going to give us minus 28q. Just consider, you start at minus 40 on a number line, then you're doing minus minus 12. So that is going to get now more closer to 0, and that's going to give us minus 28. With this particular one, we got a slight quirk. Minus 10 minus minus 10 is going to give us 0. So that tells us that q is actually 0 on this one. So don't be worried. Don't sort of sit there and think it can't be. Let's just look at this logically. If we look at this from here, and what I'm going to do is just cover these up. Look at if we solve this alone. If q is equal to 0, we can see quite clearly from this that p is going to be equal to minus 1. But of course, we would sub it in and see that. So that shows you it doesn't matter that it comes up to be a strange number or not or 0. We're just going to plug it in and solve. Okay, so that one we can see that p from there is going to be equal to minus 1. So all I've done is solve for q, show you workings, sub it in and go from there. Just be careful with the negatives. Let's look at this one. Now I could change this into 63s, or I could change this into 42s. Either way round, it's going to be messy and it's going to get pretty big. There is an alternative here, and that is now to divide through by 3. With this one, we could divide through by 7. I think I'll introduce this, but what you'll see now, what I'm going to do, I'm going to divide all of this top one by 3. If you don't want to watch this is perfectly fine. I suppose this is a bit of, sort of not extension as such, but that's what we would have, okay? So all I've done is divided each of those by 3. If it's an equation, dividing both sides by the same number will hold. What I'm going to do here now is divide both sides of this by 7, and that's going to give me x minus y is equal to 1. Now this is significantly easier to deal with because all at this stage we need to do is multiply this equation here by 2. You didn't have to take that approach and you could have gone the slightly longer way around, but I think this is going to be a bit easier. So what we've got, equation 1 is 3x minus 2y is equal to minus 22, and then we've got 2x minus 2y is equal to 2. Okay, so at this stage we've got equation 1 and we've got equation 2. If that's gone a bit over your head, perfectly fine, do it normally. Switch that one up into 63, that's the lowest common multiple, and 42 is the lowest common multiple here. I've got these values the same, they're both negatives, so we're going to subtract. So I'm going to do 1 minus 2. 3x minus 2x is just x. Minus 2y minus 2y is going to give us 0. And we need to be careful here. We're going to have minus 22 minus 2, and that's going to give us minus 24. So x is minus 24. So let's go ahead and put that in. So we've got minus, let's write in x is equal to minus 24. At this stage, I can sub it back into any of these. So we've got now 2 lots of minus 24 minus 2y is equal to 2. So I've got now minus 48. So minus 48 minus 2y is going to be equal to 2. I'm going to subtract 2 from both sides, minus 50, and add 2y to both sides is 2y. So we can see now that y is minus 25. So a slightly different approach on that. X is minus 24, y is minus 25. Now, if you wanted to check that, if you wanted to see that it works for both, we had now that x was minus 24, negative 24, and then we had now minus 6 lots of minus 25, and we're hoping that's going to give us minus 66, which it does. And if you wanted to do 7 lots of x, which is minus 24, minus now 7 lots of y, which is minus 25, that should hopefully give us now the 7, which it will do. So there we go. So slightly trickier, a slightly different approach, that's an alternative. Okay, let's do this one right here. Okay, so what I'm going to do here is simply multiply the top equation by 2. That will give me 6y and 6y. So if I just write this here, so multiplying this by 2, so multiplying by 2, we can go ahead and write that. So what I'm going to have then is 6y minus 8x is equal to 2. And leaving the bottom equation, equation number 2, we've got this scenario, and that's going to be equal to 5. So equation 1 and equation 2. We can see that this is plus 6y and this is plus 6y. These are the same, so I'm going to do 1 minus 2. If I do that, I'm going to get 0. Minus 8x minus minus 6x is going to give us minus 2x. 2 minus 5 is going to give me now minus 3. We can see, if you want, dividing both sides by minus 2, it's going to give us minus 3 over minus 2, which is going to give us x is equal to 3 over 2. If you would prefer, that's 1.5. If you would prefer to add 3 to both sides and add 2x to both sides, you're going to get the same. So this time now I can see that x is 3 over 2. I'm going to substitute that back in, and I need to substitute it back into one of the equations. If I put it into this one or this one, it really doesn't matter. So what I'm going to do is put it into equation 2. So what we're going to have is 6y minus 6 lots of 3 over 2 is going to be equal to 5. Now, if I've got 6 lots of 3 over 2, this is going to give me 9. So we've got 6y minus 9. 6 times 1.5 is 9, and that's going to be equal to 5. And all we need to do now is add the 9 to both sides. So 6y is going to be equal to 14. And then we'll simply divide both sides now by 6. Y is going to be 14 over 6, which we could simplify to 7 over 3. Have I done this right? Well, what could we do? Well, we can check it. So what I'm saying here now is that x is equal to 3 over 2 and y is equal to 7 over 3. Those don't look nice numbers. I might have done something wrong. How can I find out? I can go ahead and check. So if I look here, have I done things right? Well, that looks okay. So what I'm going to do is substitute these in. So what we're going to have then is 3 lots of y, which is the fraction 7/3. Then I'm going to subtract from that now minus 4 lots of 3 over 2, or 1.5. I'm hoping that that is going to give me now, on here, the value of 1. We can see it gives us 1. If I now do 6 lots of y, 6 lots of 7 over 3, and we're going to have now, plug in that in, plus now, minus 6 lots of 3 over 2, or 1.5, entirely up to you on how you want to write it. We're hoping that that gives us 5. We know it will, and we can see that from there. So, don't be concerned. My initial thought is, what have I done wrong? These are not integer values, and it looks a little messy. Ultimately, I'm not too fussed, as I can go ahead and solve. Let's look at this one right here. This one, I can multiply the second equation now by 4 to make this 8x and 8x, or the second equation by 3 to make this 3y and 3y. I'm actually going to do the x's. Now, all I have to do is simply say now that 8x plus 3y is equal to minus 17. Multiplying this equation now by 4, that is going to give me 8x plus 4y is equal to minus 28. I'm going to call this equation 1, this equation 2, and I'm going to do 1 minus 2. We can see these are both positives. So if I do 1 minus 2, we're going to get 0x. 3y minus 4y is minus y. And that's going to be 17 minus 28. If you're unsure, do it on a calculator. So if you're not happy, we've got now on here minus 17. Then we're going to have now minus 28. And we can see that will end up giving us 11. So minus y is equal to 11. So y must be equal to minus 11 if we divide both sides by minus 1. Let's go ahead and put that back into equation number 1. So we've got 8x plus 3 lots of minus 11 is equal to minus 17. We can see that 8x, this is going to be 33. If I add 33, I'm going to end up now with a total on there of 16. 8x is 16, and we can see that x is equal to 2. So we've got y is equal to minus 11 and x is equal to 2. So one of these is a negative solution. In the last one, we had 2 fractions. So let's see if this works. I put it back into equation 1. Does it work here? Well, if I do 2 lots of 2, and I'm talking about the second equation here, 2 lots of x, 2 lots of 2, plus now minus 11, what does that equal? 4 minus 11 is minus 7, so it holds true. So, slightly nastier, but again, the same technique. On a calculator paper, feel free to use one. Okay, let's just finish off. Now, in another video, we're going to look at an alternative way of solving these simultaneous equations, and that is by substitution. What I'm going to do instead here is look at rearranging these, and then doing exactly what we've done before. This time we've got x is equal to 2y plus 7. I'm going to rewrite this and subtract 2y from both sides. So x minus 2y is equal to 7 is equation 1. And x minus 6y is equal to 3 is equation 2. So I've just rearranged these, okay? It's entirely up to us how we do it. I like to have x plus y is equal to something, or x minus y is equal to something. So we've got now plus 1x, so we're going to do 1 minus 2. That's going to give me 0. Minus 2y minus 6y is going to give me 4y. Just think about this logically. Minus 2 minus 6. We start at minus 2 on the number line, just here, and we're going to be adding 6. So adding 6, that will take us now up to positive 4. 7 minus 3 is going to give me 4. Y is equal to 1. All I need to do is substitute this back in. I'll put it back into equation 1. X minus 2 lots of 1 is equal to 7. Adding 2 to both sides, x is equal to 9. And that is going to give us the value of x is 9. Does that work just here? 9 minus 6 lots of 1 is 3. So yes, it holds. So all I'm doing is rearranging. With this one right here, we've got a couple of choices. I could write this now as 5x minus 6y is equal to 6. This one I could write as 2y minus 10x is going to be equal to minus 2. I could have swapped that round. It really doesn't matter. I could have written that one as 10x minus 2y is equal to 2. We decide, I think this one and this one would be better, and then we simply proceed as we would before. So with this one, I could either double up that equation to make the 10x, or I could treble this bottom one to make this one right here. It's entirely up to you. What I'm going to do just to set this up, I'm going to call this equation 1 and this equation 2. I'm going to multiply this one now by 2. So that will give me 10x minus 12y is equal to 12. Equation 2 is 10x minus 2y is equal to 2. I'm going to subtract now, so let's call this 1, let's call this 2. 1 minus 2, we're going to get now 0. Minus 12y minus 2y is minus 10y. 12 minus 2 is going to give me 10. Dividing both sides of the equation by minus 10, we're going to have 10 over minus 10, which gives us now y is equal to minus 1. We can sub this back into any one we like. I'm going to put it into equation 2. We've got 10x minus 2 lots of minus 1 is equal to 2. So we can see now that 10x plus 2 is equal to 2. 10x is equal to 0, so x is equal to 0. So anything multiplied by 0 is 0. Does that work right there? Well, if x now is going to be on here, we found x is equal to 0. We found y is equal to minus 1. That works. Again, we could do these. We're kind of pushing on with time, but generally you would use a substitution method instead of the elimination. So there we go. That's simultaneous equations, linear simultaneous equations. We've used the method of elimination, and these are pretty much all you will see, generally speaking, on the paper. These sorts of things and the ones that we've looked at.